Okay, guys, we're on the next page. This is the... Wait, is this just the second page? Yeah, this is the second page. Okay, so make sure you have this one. This is our second type of special right triangle. It's a right triangle, but if you look at the picture down here, I'm actually going to skip down here with you, so follow along. We're going to just look real fast at this entire triangle. Actually, let's use a nice, pretty color here. I like purple. Okay, so if you look at this whole triangle, what kind of triangle is that? What? I will tell you. It's an equilateral triangle. That's what we're starting with here, okay? Not necessarily because of any reasons other than I'm giving that information to you. So we're starting with an equilateral triangle. So notice how I have my 60-degree angles there. Well, if it's equilateral, that means all the sides are the same, right? So we know this is going to be congruent to this, and it's congruent to this whole thing. And then I know all the angles are going to be the same. So 60, 60, and 60. So that's what we're starting with. But this lesson is about special right triangles. So in fact, we are actually going to focus only on the right triangle that divides this equilateral into two pieces, okay? So that's what we're going to focus on in just a moment. Cool. Let's go over this together. I'll do like this first part with you, and then I'll give you some time to practice and try out this these questions below, and then you can do the next video to watch it. So there will probably be 4 videos total. Okay. So it says to use numbers 1 and 2 in this triangle to name the special right triangle. So let's take a look at those numbers. I told you already, since this is equilateral, all of these are going to be 60. But if I'm just looking at the measure of angle 1 right here, that's going to be half. So this has to be 30 degrees here. So the name of this special right triangle is called a 30, 60, 90 triangle. Isn't that a clever name? They're very clever, these people. Okay, so if you look at triangle BST, as I said, that is an equilateral triangle. Okay, what we're going to do now, though, is just focusing on that bolded right triangle. We're going to identify TS, ES, and TE and fill in the blanks with the corresponding angles. So the first one, out of those 3 legs or sides, which one is the shorter leg? So we can see that ES, that's this one right here, is the shorter leg, and it lies opposite the 30-degree angle. Remember how we said that the smaller sides across from the smaller angle, and so on. So the longer leg, not the longest side, but just the longer leg, is going to be TE, and that's across from the 60-degree angle. And so that means TS is the hypotenuse, which is always across from the 90-degree angle. So that's just important information for you to have later on. Okay, you need to know what short leg, long leg, and hypotenuse is. Alright, so we're going to find each of the following, which we kind of already did find the measure of angle 2. That's 60 degrees. Great, this is a little repetitive. Okay, TS, what is TS? That's going to be 6, right? Only because this is equilateral. ES is, if you'll notice, this whole thing is 6, so ES is going to be 3, half of that. Okay, so for number 4, it says, using Pythagorean theorem, find TE. Okay, so let's do some Pythagorean theorem, shall we? I'm going to go over here in this space provided. So let's call this x, because we don't know what it is. So we're going to do x squared plus 3 squared equals 6 squared, right? So I'm using this right triangle and just doing Pythagorean theorem. So x squared plus 9 equals 36. So x squared is equal to, we're going to subtract the 9 from both sides to get 27. But then we have to square root both sides. And it's not a perfect square. So let's break it down into 9 and 3. And then 9 breaks down into 3 and 3. So the length is 3, right? Pairs come out. That one pair comes out. What's left is this 3 right here. So TE is 3 square root of 3. Okay. So we're only going to do that once. I know there's a chart later on, but I'm going to kind of skip ahead and tell you what the pattern here is going to be. Maybe these weren't the best numbers to use. because this 3 is always going to be the square root of 3. The number here is going to change depending on the length of the hypotenuse. So in general, here's this important fact you need to know, right? Need to know. Don't lose these notes because this is for your open note quiz next time. Okay, you need to know this fact here. In a 30, 60, 90 triangle, so here's my 30, 60, 90 triangle, if the short leg is x, so here's short leg, then the long leg will always be, are you ready for this? X square root of 3. And the hypotenuse will always be 2x. Okay, so if you imagine that this is my equilateral triangle drawn, like so, we can clearly see the hypotenuse is twice the short leg. And then using Pythagorean theorem, you're always going to get that the long leg, so here's the long leg, is whatever the short leg is times the square root of 3. So, we're going to write that out here. Hypotenuse is equal to, what do they want, variables here? No, I'm going to write out in words. 2 times the short leg. The long leg is always equal to the short leg times square root of 3. So there's another very important piece of information to memorize, but it's basically the same as this triangle here that you need to know. Okay? Okay. So I'll do a couple with you here, and then what I'd like for you to do is, well, how about this? I'll do the chart with you, and then I'll let you do 7. Okay? You can practice that, because you need to be able to practice this without me helping you. All right. So let's do A together. Oh, by the way, we have to go to the 3rd page. So A, B, C, and D is on the 3rd page. Cool? Okay. All right. So in this chart here for A, we label the short leg. Okay, that's 6. That's given to me. The long leg is, well, what is the long leg? I don't know yet. Let's fill in what we do know. The hypotenuse is 12. Okay, but based on this triangle here, if this is my x, then the long leg is x square root of 3, right? And you can clearly see the hypotenuse is 2x. 12 is 2 times 6. So what would the long leg have to be? 6 square root of 3. You can always verify with the Pythagorean theorem, but that's just extra work. Remember we talked about using these methods, these kind of, like with Pythagorean triples, it helps us if we memorize these tricks, because then we go faster on the SAT, as long as you understand where the tricks come from. Okay, and these ratios are going to be, hypotenuse over short leg is always going to be 2. And when you do the long leg over the short leg, that's always going to be square root of 3. See how the 6's cancel out? Okay, let's do B. So if I have the long leg as 4 square root of 3, the hypotenuse is 8, what is the short leg? Well, I know it's half of the hypotenuse. It's also the number outside of the square root of 3. So the short leg has to be 4. And you can check that ratio. 8 over 4 is 2. 4 square root of 3 over 4 is just the square root of 3. Right? Isn't this fun and easy? All right. Let's look at C. So the short leg is 15. The long leg is 15 square root of 3. The hypotenuse is 30, right? The hypotenuse is 2 times short leg. So it goes x square root of 3, and 2x. You with me? This ratio would be 2, and this would be the square root of 3. All right. And last but not least, what color should I do? Oh, I haven't done purple. So D, this one's tricky. Actually, this one's easy. I'm sorry. But it is a little different because it only gives you the hypotenuse and not the other two. But we can do that, right? If the hypotenuse is 2 times the short leg, you just divide that by 2, which is 8. Always find the short leg first. Then, once I have the short leg, I just need to multiply it by square root of 3. So the long leg is 8 square root of 3. 8 square root of 3, 8. Right? The ratio of hypotenuse to short leg is 2, and long leg to short leg is square root of 3. So you can see this pattern is going to happen every time. Now, there might be some differences And you will have to possibly rationalize here again. So you might get a little stuck maybe on number... that was easy. That was not too bad. D is a little tricky, but other than that, they're really not too bad. So go ahead and do number 7. They're actually not bad. Okay? And then I will briefly go over them in video number 4. Bye-bye.